This is lesson 7.5, solve special types of linear systems. Okay, doing our warm-up. First two questions are nothing special. They're just asking us to graph the systems. So, you guys should have went ahead and did it already, or you should be working on it. I'm going to do it over here. Remember, first thing you would do is I'm going to take this equation. I'm going to show my work over here. And to graph it, I'm going to write it in slope-intercept form. So I'm going to solve for y. So I have minus 3x on both sides. And I'd have 2y equals negative 3x plus 10.
Please excuse the interruption. All culinary arts students, please go to the comments for your field trip. All culinary arts students are released to the comments. Thank you.
Alright, so continuing with this. Alright, so, boys and girls, back focus. So once I've written this in slope-intercept form, we can identify the slope was negative 3, 2, and the y-intercept was 5. And then, of course, we graph by the y-intercept first. And then we use the slope to find the other points. Down 3 over 2. So 1, 2, 3, 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. Remember, you really only have to have 2 points. It's nice to have 3 because 3 points make a straight line. The more you do, it's just the easier because it's connecting dots. A little bit easier. So we did the first line. And then I'm going to do my work for the second line. Same thing. 3x plus 2y equals 2. I'm going to minus my 3x. I have 2y equals negative 3x plus 2. We divide by 2. Y equals negative 3 over 2x plus 1. And on this one, I see my slope is negative 3/2, and my y-intercept is 1. Graphing that, we do y-intercept first, and then negative 3, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And the opposite way over there. Okay. Oops. Okay, so that's how we should know how to graph our lines. Okay? Nothing new. We take an equation, we solve it for y, so we have it in slope-intercept form. Honestly, this is the one part that I keep working with students with, is that extra step just to help you, is go ahead. It doesn't take much work to write down what the slope and the y-intercept is. It kind of helps you make sure that you don't overpass like the negative side. Because a lot of times I've had students when they've left it as y equals, and they write down, they just graph it, they've forgotten the negative side. So if you write it down, that's what you can go back to. Remember, point slope, we need a point, we need a slope. In slope-intercept form, we need the slope, and we need the y-intercept. So it's in the name what we're using. This slope-intercept form works best for graphing the line. I'm not going to do number 2 just for a reason. It's nothing different. It's going to be the same thing, but actually later on today's lesson, we'll probably go back and graph this one anyways. So today's learning goal is I will solve special types of linear systems. You guys just took your quiz over linear systems, finding that one answer. Remember, a linear system, maybe review this because we had these on the snow day. Let's do 12 minutes. 5, 1, 7. Something like this. So mainly we have a linear line. 2x plus 4y equals 15. A linear system is when we have two or more linear equations, and I'm telling you that my solution is one coordinate point, meaning there's one answer that I can put a number in for x and a number in for y that would make both of those equations true. Okay? Well, we're going to learn today how that's not always going to be the case where there's just one answer. So, I'm going to hand out this green part that we will put in our foldable, or our spiral. Give one to Henry when you get it. Alright, so far in the lessons 1 through 4, what we worked on, and we took our quiz, was linear systems with exactly one solution. There's only one point. However, there are two other possibilities that we can have. So on this sheet, you're going to see we can have lines that intersect, and that's what we've worked on. Everything that we've solved up to this point, if we graph each equation, the lines would be intersecting and they would have only one solution. And that one solution is that intersection point. Wherever they intersect, that was the solution. Well, today what we're going to look at, and this isn't going to be that much work, I think you guys will catch on to it pretty quick, it's not that confusing, but today we're going to look, if the lines are parallel, there's no solution. And that should actually make quite a bit of sense. Because if I'm asking you for a solution, what point is making each statement true? Mainly I'm saying which point is on both lines. Well, if the lines are parallel, and I choose this point on this line, obviously that point, if the two lines are parallel, is never on the other line. So there's never a point that the two lines share. If they shared a point, they would intersect. So parallel lines have no solution. The last one is if the lines coincide, we have infinite many solutions. Meaning, not just any number. You can't just say, oh, I'm going to do 1, 5 and negative 17, 68. No. Your infinite solutions can be any point on the line is the answer to the other equation. And they say lines coincide. That's just a fancy way of saying they're the same line. That they have the exact same slope and they have the exact same y-intercept. If the lines fall right onto each other, they share every single point. And once again, well then that makes sense. Well yeah, every point's the same. Infinite amount of solutions because lines go on forever. So, this was warm-up 1 that we just did. That 3x plus 2y equals 10, 3x plus 2y equals 2. Remember, we couldn't just graph it. This is in standard form. We could not just graph that. We had to go to another form, so we used slope-intercept form. But we graphed it. There was our two lines. Their lines are almost as pretty as mine. Close. But when we look at this, we now make up our decision. Does it have no solution or infinite amount of solutions? Should be fairly obvious. It has what?
No solution.
No solution. There's no coordinate point I could choose on the blue line that would also be on the red line. Visually, it makes total sense. Now, do we have to graph every single line to come up with that? Is there a way I could be able to look at just my two equations, do a little work, and find out if they are parallel? Maddie?
You already know that the slope's gonna be the same, and their y-intercept's different, so you can tell that they're gonna
So we're getting ahead because that's later in the notes, but I wanted to see if you guys are knowing. We know if we solve two lines, we put them in slope-intercept form. If they have the same slope, that means their line steepness is going to be the same and their direction is the same, whether it's a positive or a negative slope. So if they have the same slope, but they have different y-intercepts. And that part's important. Does that make sure, if we have the same slope, does that mean it's automatically parallel lines? No, not quite. We can have the same slope, but if we have the same y-intercept, they're going to be the lines that coincide. They sit right on top of each other. So we have to have different y-intercepts. The y-intercept, all that does in reality is that just spaces the two lines out. The bigger the difference in my y-intercept, which is here and here, the bigger the difference, the farther the two lines are spaced out. The shorter the distance, the closer they are. Alright, so this was warm up 2. I didn't do this one because we're going to do it here, or we can just look at it. Real quick, what they did, if we did this first line, I'm going to do it now. Here was x minus 2y equals negative 4. Obviously, we minus x. Negative 2y equals negative x minus 4. We divide by our negative 2. And y equals positive 1/2 x plus 2. Okay? When we graph that line, here's the y-intercept, and then they said the slope was 1 over 2. So up 1 over 2, up 1 over 2. The blue line, that was our given line. On the second line, well, here was the slope, 1/2. There's my y-intercept. They were the exact same. When the two were exactly the same, so I'm using purple this time, it would have still been, okay, 2 up 1 over 2, up 1 over 2. We would have got the exact same line. So on this one, our lines coincide, which means how many solutions do we have? Infinite. Now, on a test, on MAP, on EOC, on the end of this chapter, if I said, tell me at least one solution. You can say there's infinite solutions. If I said, give me one possible solution, you could choose any point that you know. I always use the y-intercept just because it's easiest. I'd say, well, 0, 2 will make both equations true. I could use negative 4, 0. That would make both equations true. And remember, what we're telling you when we find solutions, I did this with my other math class, when we found solutions, what I'm telling you is the coordinate point, like let's use 0, 2, means if I went in this equation, if I use the coordinate 0, 2, remember that's x and y, that if I went in here, I'd say x was 0 minus 2 times 2 equals negative 4. That this, when we work out, should become a true statement. Well, negative 2 times 2, I'm going to have negative 4, and 0 minus negative 4, we have negative 4 equals negative 4. It's true. I can use the same equation, or same coordinate for this equation. Y is 2 equals half times 0 plus 2. Half times 0 is 0. So that just goes away, and we'd have plus 2. 2 equals 2. That solution that we chose made both of our equations true. And since there's infinite, I can use any point along this line. Any one of them I want. Does that make total sense for you? So, besides graphing it, when we know that they have infinite, we will have the same slope and the same y-intercept. So lines coinciding are similar to parallel. The only difference is lines that coincide, they have the same y-intercept. So they lay right on top of each other. So here we go. They gave us a system of linear equations. And I want us to find out if we have no solution or infinite. Can I tell just by looking at the two right now? No. They're almost in standard form. This one can't be because it's a negative. But no. So our first step is we want to go ahead and solve for y, or we want to find the slope and the y-intercept of each line. So I'm going to pause the recording, quickly work through the two equations, check with your neighbor. If you want to do one line, have your neighbor do the second one, and you guys check each other's, I'm okay with that. So check them quick. All right, so some people said they have the same, like y equals as I did. So if we went ahead and look at this, I'm going to look at the first line, and I'm going to get my slope to be 1, and my y-intercept was -8. On this one, my slope was 1/2, and I'd have a -5. So, how many solutions do we feel like we are going to have on this one? Yeah, and Tim said the same thing. I don't know why the thing said no solution or infinite. First thing is, we can eliminate no solution, right? If it was no solution, the lines would be parallel. Are our lines parallel? Well, I know right away because our slope is different. Not by much. One's going, if we look at this, this is technically like 1/1. So this one's going up 1/1. The other one's going up 1/2. So not much of a difference, but it's going to be angling that after time they will cross. So they're definitely not parallel. Well, then the other thing is if the slope isn't the same, can the lines coincide? No. So we know it's not no solution and it's not infinite, so there's going to be one intersecting point. So we would say this one, choice C, one solution. And when we have one solution, we will find that there is just one xy. Okay, let's go ahead and do the second one. Same thing. Why don't you get with a partner? You do the, well, I like, don't do it that first line. The first line is easy. Do we know what our slope is?
No.
Yeah, it's 2.
Yeah, it's 2. It's already set up in slope-intercept form. What about for my y-intercept? -4. All right, I'll pause real quick. Rewrite this equation in slope-intercept form. Identify the slope and the y-intercept, and then we'll choose what we have. All right, our second line, -6x plus 3y equals -12. What was our slope?
2.
Yeah, 2. Oh yeah, culinary, you guys better go. Now you're 2 minutes late. You were 20 minutes early, now you're, oh, you want the worksheet? Here you go, Rob. Alright, so focus back up here. We have our slope as 2, and our y-intercept was -4. Because they are the same, what does that tell me? Maddie?
There's going to be infinitely many solutions.
Good. And once again, just to make sure you guys understand, infinite many solutions, what does that mean? Can I come up with any equation I want, or any coordinate that I want?
No.
No. What does it mean, infinite solutions, Grace?
Any coordinate on that line. is
Very good. Any coordinate on the line. Alright, we're almost done actually. This stuff's kind of what we're going to just put in our notes. I will be putting, when I glue mine in, I forgot I need to make that little video show on my spiral notebook just to update it for you guys. So I'll try and get that done today. But I'm going to glue this page, that green little foldable for you, and then I'm going to write some of this stuff underneath. You'll see on the next slide. But we've already done this. So reviewing, what do we know about these lines? So we're going to talk about the slope and the y-intercept. If we have intersecting lines, which gives us one solution, what do we know about the slope and the y-intercept? The slope will be different. Does the y-intercept have to be different?
No. The slope because they could cross on the y-intercept.
Yeah, yes.
Good. So when we have intersecting lines, our slope will have to be different. Okay? Our slope is going to be different. So I'm going to say just M is different. But we're going to say our y-intercept. When's the only time it would be the same, Daddy?
It's if it was intersecting on the y-axis.
Very good. If our y-axis, that y-intercept was the intersection, then it'd be the same. So it can be the same or different. Let me make sure I don't have it something else. Oh, I do. Yeah, we do. Fantastic. I'm doing extra work that I don't need to. Alright, so one solution. The slopes will be different, and the y-intercept either has to be the same or different. And like Connor told us, the only time it's going to be the same is when that y-intercept is our intersection point, which happens. If we have parallel lines, I'm going to make this note over here though. Parallel lines means how many solutions, no solution. I was going to write it on the side. I forgot I had it on there. More work I was trying to do for myself. So, parallel lines, no answer, no solution. The slopes are the same. The y-intercept has to be different. So there's never any crossing. The same lines, the lines coincide. Infinite solutions, slopes the same, y-intercept's the same. They lay right on top of each other. So, last two. I'm going to pause. Work with a partner. Really, if you want to save time, have you do one line, your partner do the other line, and then compare your slopes and y-intercepts. Let's do these two and tell whether there's one, no, or infinite. I'll pause, and then I'll have you look at it. All right, looks like a lot of people are finishing, so looking at number one. The first line, 4x plus 2y equals 12. I ended up finding a slope of -2 and a y-intercept of 6. Y equals -2x plus 8. My slope was -2 and my y-intercept was 8. So I have the same slope, but then my y-intercepts were different. What does that mean my lines are?
Wait.
What's that mean if I have the same slope with different y-intercepts? Why? Perfect. It means my lines are parallel. They have the same steepness. They have different y-intercepts, so they are parallel. No solution. And number two, we found the slope to be 2/5 and the y-intercept to be 1. We found the slope to be 2/5 and the y-intercept to be 1. What does this tell me? Reagan, what do you think? Infinite. The two lines coincide. And last question I'm going to ask before I get you started. What does that mean once again when I say you have infinite solutions? I know the lines are laying on top of each other and coinciding. But does that mean I get to choose any coordinate I want?
No.
I think you gave that to me last time.
Yes, I did.
So someone else, what's that mean if it's infinite? Connor?
Any point on the line.
Perfect. Any point on the line. Alright, today, you guys still have about 7 minutes that you're going to work. We're going to do worksheet 7.5. I love how we say 7.5. All of the worksheets. Skip. Okay, so you're not doing all. But you're going to skip 7, 6, 7, 12, 13, 18, and 19.